Imagine a place where the laws of physics seem to unravel, where time and space intertwine in a way that defies logic. We're talking about black holes, those mysterious entities that devour everything around them. Have you ever stopped to think about what really happens inside them? The gravity is so intense that even light cannot escape. Have you considered the absolute darkness? But what if I told you that inside this cosmic abyss, there's more than just emptiness? Imagine a point where the density is so extreme that the physical laws we know simply don't apply. This occurs at the center of a black hole, where gravity becomes so intense that nothing can escape its pull, not even light. This idea challenges our understanding of reality, as we usually think of density and gravity as factors that can be measured and understood. But at the singularity, all of this collapses. Scientists have intriguing theories about what goes on there. Could there be a singularity, a point where everything converges? Or perhaps a passage to another universe? This phenomenon provokes a series of curious effects. The gravity around a black hole is not just strong, it distorts the perception of time and space. For someone approaching a black hole, the experience is radically different from that of a distant observer. While the person approaches the singularity, time seems to pass normally for them, but for the external observer, time appears to slow down. It's as if reality splits into two distinct experiences. What happens to matter and time? Is it possible that, when crossing a black hole, you might experience something entirely different? Visualize the curvature of space-time as a fabric that is stretched and deformed by massive objects. A black hole is like a heavy ball placed on a trampoline, creating a depression so deep that it becomes impossible for anything approaching it to escape. This is the essence of the singularity, a region where space-time curvature reaches its extreme. It's a place where gravity becomes so powerful that it defies logic and reason. Another intriguing aspect is that, at the singularity, the notion of space and time as we know them may not make sense. Instead of there being a before and after, everything could merge into a single moment. This idea is so unsettling that even physicists have difficulty accepting it. The singularity forces us to reconsider our fundamental concepts about the universe. Finally, the singularity represents a frontier of our knowledge. It reminds us that no matter how much we advance in our understanding of physics, there are still limits we haven't crossed. The quest to understand the singularity is, in fact, the quest to understand the very nature of space and time. What happens inside? It remains a mystery that continues to intrigue scientists and curious minds around the world. The event horizon is one of the most fascinating features of a black hole. Imagine it as an invisible line, a boundary that, once crossed, prevents any return. For an external observer, this limit is a point of no return. It's like looking into a bottomless pit and realizing that, once something falls in, it will never come back. This idea is both captivating and terrifying because it makes us think about the consequences of crossing that line. As an object approaches the event horizon, a curious phenomenon occurs. Time seems to slow down. For someone watching from afar, the object approaches the horizon more and more slowly, as if it were in a struggle against time. It's like watching a movie in slow motion, where the protagonist seems trapped in an endless moment. This perception is a consequence of the intense gravity of the black hole, which distorts the fabric of space-time around it. For the object approaching the horizon, however, the experience is completely different. For it, time continues to flow normally. This leads us to question the nature of time and how it is perceived. What is real? What is an illusion? These questions become even more complex when we think about how different observers can experience the same sequence of events in such distinct ways. This event horizon phenomenon shows us how gravity can shape reality in ways we can't imagine. What happens to the perception of time when the normal rules no longer apply? It's an intriguing question that defies logic and makes us reflect on the nature of time itself. Relativity is a powerful tool, but even it encounters limits in the face of a black hole's singularity. In the end, the event horizon is not just a physical boundary. It's a symbol of the limits of human knowledge. As we explore the cosmos, we are constantly confronted with the idea that there are things beyond our comprehension. The event horizon reminds us that, even in science, there are mysteries that may never be fully unraveled. This uncertainty is part of what makes exploring the universe so exciting and challenging. The event horizon is a fascinating concept marking the boundary of a black hole. Imagine you're approaching a black hole, and as you get closer to this surface, what happens to time? For an external observer, it seems like time stretches, as if the object were slowing down. This illusion is caused by the intense gravity that distorts space-time around the black hole. So, what seems like a visual phenomenon is actually a profound alteration of the laws of physics we know. Now, if you were the object falling toward the black hole, the experience would be quite different. For you, time would continue to pass normally, with no noticeable deceleration. This creates a kind of paradox, where the perception of time varies depending on the observer's position. While from the outside it seems you would never enter the black hole, from your point of view, you would continue your trajectory uninterrupted until you cross the horizon. This phenomenon raises questions about the nature of time and how it can be affected by gravity. What is time, after all? Is it a universal constant or something that molds itself to the circumstances of the universe? The answers to these questions remain the subject of intense research and debate among physicists and philosophers. The interaction between gravity and time forces us to rethink concepts that once seemed unquestionable. Moreover, the perception of time concerning the event horizon makes us reflect on the fate of matter itself. What happens to an object that crosses this boundary? Does it become part of a hidden world where the rules we know no longer apply? This mystery continues to intrigue scientists, who seek to better understand what it really means to go beyond the event horizon. Lastly, this issue also has implications for our understanding of the universe as a whole. What happens inside a black hole remains an enigma, and the event horizon is the key to unlocking that mystery. The way we perceive time and gravity around these phenomena can ultimately help us better understand the very structure of the cosmos and the limits of our comprehension. The question of what happens to the information that falls into a black hole is one of the most intriguing in modern physics. Over time, quantum physics and relativity have offered conflicting views on the nature of the universe, and when it comes to black holes, these views come into conflict. The information paradox suggests that when matter and information are sucked into a black hole, something fundamental about the nature of information may be lost. Or is it? One of the central points of this debate is the idea that information is not destroyed, even when it seems to be absorbed by a black hole. This idea contradicts classical intuition, where matter can be destroyed, but information, according to quantum mechanics, is considered an entity that must be preserved. This preservation of information leads to fascinating theories, such as holography, which suggests that information could be stored on the surface of the event horizon, as if the black hole were some kind of cosmic hard drive. These theories challenge our understanding of physics and raise new questions about the nature of spacetime. The notion that information could be encoded on the surface of a black hole implies that, in some way, we could recover information about the matter that fell in. This idea opens the door to a series of speculations about the structure of the universe and how information relates to gravity. Additionally, the question of information in black holes also intersects with the quest for a unified theory of physics. Scientists are increasingly trying to understand how gravity and quantum forces interact. The relationship between information and black holes could be the key to deciphering these mysteries and potentially reveal a new layer of understanding about how the universe operates at its most fundamental levels. Ultimately, the fate of matter entering a black hole is still an open question, but the debate over information leads us to reconsider what we really know about the nature of reality. Black holes, these fascinating cosmic traps, are not just an astronomical phenomenon, but also an invitation to explore our understanding of time, gravity, and most importantly, information. The question of what happens to the information that falls into a black hole is one of the great dilemmas of modern physics. The information paradox, as it is called, raises a series of intriguing questions about the fate of matter and information in extreme situations. When an object is sucked into a black hole, at first glance, it seems that the information contained in that object is lost forever. However, this idea goes against a fundamental principle of quantum mechanics, which states that information cannot be destroyed. Many scientists have explored the possibility that, even if matter is absorbed by the black hole, the information associated with it does not disappear completely. One of the main theories that have emerged in this context is the holographic theory, which suggests that all the information of an object that falls into a black hole could be stored on the surface of the event horizon. This idea is fascinating because it implies that the reality we perceive could be a projection of information stored in a lower dimension. Proponents of holography argue that, just like a holographic image can be reconstructed from an interference pattern, the information that seems to have been lost could, in some way, be recovered. However, this recovery would not happen in the traditional way we know. Instead of re-emerging in its original form, the information could manifest in an entirely new way, challenging our understanding of what information is and how it operates in the universe. Another line of investigation suggests that information could be related to what we call the entropy of the black hole. When matter enters a black hole, the system's entropy appears to increase, which is consistent with the second law of thermodynamics. This raises questions about how information could be encoded in the black hole's entropy and thus be returned to the universe, even after an object has fallen in. These theories have profound implications not only for physics but also for philosophy. They challenge us to rethink the nature of reality, information, and even time. The possibility that information persists, even under extreme conditions, invites us to reflect on what we truly know about the universe and the nature of existence. These debates continue to evolve, and each new discovery brings us a little closer to understanding these cosmic mysteries. So, have you ever thought about the implications of all this? Imagine yourself being sucked into a black hole, where time and space distort in ways our minds can barely comprehend. Would you become a time traveler? Or perhaps a subatomic particle lost in a parallel universe? Now, reflect. Could the answer to the deepest questions of existence be hidden in one of these gigantic cosmic monsters? And if, somehow, we could cross that boundary and come back, what would we bring back with us? These are questions that challenge our understanding and, at the same time, encourage us to explore further. What do you think? What happens to the information that enters a black hole? Does it really get lost? Or is there a way to recover it, even if in a mysterious form? Stay tuned to our channel because science is full of enigmas waiting to be unraveled. Leave your theories and questions in the comments, and don't forget to subscribe for more content that will make you rethink the universe. See you next time.